Thank you to Megan and to Community Forest International for inviting me to come participate in this workshop. I'm really excited to get to share some of the research that we're doing in the US with you and then participate this afternoon as well. And so, here we go. As Megan said, I help coordinate this Adaptive Silviculture for Climate Change project, which is an experimental study across different local ecosystems in the US. And so as managers, we know that our climate is changing. And so our big question is, how do we manage our forests to cope with this change? And so the Adaptive Silviculture for Climate Change, or ASC project is how I refer to it, is really trying to look at specific examples of how we as managers can look at local ecosystems and how to adapt to these changing climates and test effectiveness of different treatments across the landscape. So I also am a member of the Northern Institute of Applied Climate Science, or NIACS. And this, as Megan said in my intro, is a team of climate specialists and educators and outreach specialists really looking at climate adaptation strategies and carbon. And they've come up with a forest adaptation resources framework that we use for the ASC project. And so we have a nice US Forest Service GTR, but it's also available online. And so I'll talk a little bit about some of the strategies that have come from that as well. Stay right there.
Yeah.
Okay.
It's awkward, but you gotta stay very close to it.
I know, I'm used to walking around too, so. Awesome. So this is the website as well for that forest adaptation resources. And so it's just forestadaptation.org is where you can go, but this is the framework and the process that we use for the Adaptive Silviculture for Climate Change framework.
So you just mentioned GTR. What does that mean?
I'm sorry, it's a general technical report.
Okay.
So it's just the publication.
Not suit that leaves on it.
No, exactly. Thanks for clarifying. All the acronyms, you know. So within this framework, basically, we've done a lot of work interviewing managers across the US, and we always hear four key themes when it comes to climate science and climate adaptation. So it's climate change is too big and too complex. Information is not relevant enough to our local context. One size fits all is insufficient, and there's not enough real world examples. And so the NIACS framework for this climate change response framework is really trying to address those four questions through our process. And so we have a lot of partnerships to really try to tackle this big and complex issue. We are working with all kinds of partner organizations across the Midwest and the Northeast of the United States. And then we create these vulnerability assessments. And so they're really looking at specific local, eco-regional vulnerabilities to the different forest ecosystems across the Midwest and the Northeast. And then come to this forest adaptation resources process. So this is really our framework to come up with different climate adaptation management strategies for those local contexts, and then creating adaptation demonstrations on the ground. So actually providing those local examples of what this could look like. And just some other efforts that NIACS helps facilitate. There's a Climate Change Resource Center, which is an online tool from the U.S. Department of Agriculture and the U.S. Forest Service that just provides some different tools and resources, and it's basically a clearinghouse of some of the science that's out there on that website. The NIACS, the U.S. is split into what we call these climate hubs based on regions. And so NIACS helps facilitate and run the Northern Forest Climate Hub in the Midwest and the Northeast of the U.S. as well. And then we have researchers within our group that have created this climate change tree atlas. And so it's really looking at species shifts across the eastern half of the United States, so everywhere east of the 100th meridian, and looking at species shifts and species distributions under a changing climate. And all of these tools are things that we've used to help inform our Adaptive Silviculture for Climate Change project. And so again, this is really trying to take some examples of what can adaptive silviculture actually look like on the ground and provide tools and resources to managers trying to manage for a changing climate. And so we, of course, want to foster resilience to impacts of climate change and enable adaptation to uncertain climate futures. And so the ASCC project really is this collaborative, co-generated effort between managers and scientists across the US. We have our key PIs, or principal investigators, who have come up with the theory and the framework of this process. And then we have site leads and key managers who are scientists and the lead managers across the different forests that we're looking at. So we have some in Colorado, Minnesota, Georgia, Montana, and New Hampshire currently. And then we're also going to be doing this process at the Petawawa Research Forest in July. And we're also beginning to think about urban contexts as well. So we're expanding. And so the two main goals of ASCC are really to look at this multi-region study, focusing on ecosystem-specific climate change adaptation treatments that involve the input and the expertise of these local scientists and managers. So as managers, you know your forest best. You know what the soil is, what the climate is going to be like, what your species are, and how to manage for them. And so we really want to make sure that we're not just bringing in the science, but making sure that that management voice is heard throughout this process as well. And then the second goal is to really provide these tools and approaches to help integrate that climate change thinking and adaptation into our natural resource management and silvicultural decision-making on the ground. And what we do is we use this spectrum of adaptation treatments from Connie Millar's research, and it's looking at this resistance, resilience, and transition spectrum of adaptation options. And so in the US, we also know our climate is changing, temperatures are increasing, precipitation is increasing as well, except for in the Southwest in Hawaii, and that precipitation is coming in those really heavy, less frequent events. And we also know that there is an increase in our frost-free season length. And so, as Anthony was mentioning, we have to think as managers about all of these different things, from invasives to past management history, to what are our desired future conditions, all the different goals and objectives of managers and our values, whether it's wildlife or recreation. And now we have to think about climate change on top of all of this as well. And so again, the main question our ASCC project is really looking at are what actions can be taken to enhance the ability of a system to cope with change and meet those local goals and objectives. And so as managers, we have an idea in our head of what that desired future conditions should be. So we have our current condition, which is on the left, and that future condition, which is on the right. And so we create our goals and objectives of what that future condition will be. But under a changing climate, it's going to pull that future condition into this uncertain trajectory. So how do we as managers determine what we need to do to manage for that desired future condition under a changing climate? And so this is where our spectrum of adaptation options comes in, where we're really thinking across from resistance, where we're managing more for the persistence of the ecosystem and making sure it's still recognizable and has that same character, all the way to something that's more of a transition or response, where we're really managing for that change and the ecosystems have fundamentally changed to something different. The structure and the competition might be very different from what the current condition is on the ground. And so just to dig into these a little bit deeper, so resistance, the definition that we use is really to improve the defenses of the forest against anticipated changes or directly defend the forest against disturbance to maintain relatively unchanged conditions. And so for this, we're really thinking over the short term, and we're really focusing on those high value species that we really want to conserve, or those high values of that stand that we're really interested in maintaining. And so this could be a threatened and endangered species habitat, or maybe we're trying to get rid of an invasive disease or insect. Those kind of fall underneath that resistance adaptation option. And so with resistance, again, we have our current condition, and that future desired condition is something that's very similar to the current condition on the ground, even as we move toward that climate change trajectory. However, we know that as we move forward in time, the amount of capacity and investment and risk is going to increase, trying to maintain that current condition into this uncertain climate future. So the second adaptation option is resilience. And our definition for this project is really to accommodate some degree of change, but encourage a return to a prior condition after disturbance. So this is kind of what we're calling the rubber band strategy, where we do allow disturbances to come in, but the stand and the ecosystem is able to bounce back to that prior condition and maintain a relatively unchanged composition and structure. And so things like prescribed burning might be a good option for this, especially in ponderosa pine stands, selective thinning, or maybe planting an increase of some of the rare species within that current stand that exists within that forest ecosystem. And so with resilience, again, we have our current condition and the desired future condition is only slightly changed, but it's able to bounce back, which is what that squiggly line is representing from those different disturbances. However, with this option, we also know that the amount of capacity and time and risk as we move forward toward this future is also going to increase over time as we move toward that uncertain climate change trajectory. Does anyone have any questions about this so far? Okay, awesome. And then our third option is really this transition adaptation option or response. So we're intentionally accommodating change and enabling ecosystems to adaptively respond to those changing or new conditions. And so with this, what do you think are some different options that we could use silviculturally, what that would be considered a transition adaptation option?
Migration, system migration.
Yep, the system migration is a great example. What else?
What about just like selective weeding,
Yeah, like selectively getting rid of a specific species. Another option is creating more of those corridors for species transitions as well. So making sure we're preventing fragmentation, increasing forest corridors, that sort of thing. Those are all transition options. And so with transition, that desired future condition is something that is accommodating that change as we move into the future. And so up front, the amount of risk in time and capacity and effort and resources needed to transition that ecosystem are going to be pretty steep. But as we move toward that future condition, the amount of investment and risk might actually decrease over time as we transition to this different structure and composition. And so again, just to summarize, the ASCC project really is looking across this spectrum of adaptation options, from resistance all the way to transition. And so the Adaptive Silviculture for Climate Change, or ASCC project, is across the US. We have a series of the key PIs or leaders who came up with the theory and the concepts for this project. And so those include Chris Swanson and Maria Genoviak from the Northern Institute of Applied Climate Science. Linda Nagel is the lead researcher on this project, so this really has come from her ideas and her research. And so Linda, myself, and then we have a postdoc named Chris Flooney, who are all at Colorado State University. And then Jim Golden with the U.S. Forest Service Southern Research Station was also a part of this lead team. There were also some key collaborators who are really those lead scientists who were the thought experts to help us define what this resistance, resilience, and transition would be for this project. And so those are Dave Peterson from the Pacific Northwest Research Station, Lisa Gagno, who's a statistician at Oregon State University, and then Connie Millar, whose concepts really are that resistance, resilience, and transition. And then we have the 5 sites that are currently being implemented across the US. So the first one that was created was the Chippewa National Forest in northern Minnesota. We have the Dartmouth Second College Grant in northern New Hampshire, the Jones Ecological Research Center in Georgia, the San Juan National Forest in Colorado, and the Flathead National Forest in northern Montana. And so for the ASCC study design, this is an experiment, and so we want to make sure we have some criteria that are consistent across all of these sites. And so, of course, everyone has to have the 4 treatment themes. So we really are pushing people to think about, okay, what is business as usual here? versus what is a transition adaptation option that we can really be thinking about in this local ecosystem. And so all of the sites look across the spectrum, and then we also have some control plots that are no action. And then each of them are replicated a minimum of 4 times. So we want to make sure we have 4 different plots of resistance, 4 different plots of resilience, and 4 of transition, and 4 of no action. And the total stand size at all of these units is 400 acres. So each one across Minnesota, Colorado, Georgia, New Hampshire, and Montana are 400 acres, except for the Minnesota site is actually 500 acres. They wanted to have a little bit more to play with. And then we want them to be, the stands are all 20 to 25 acres in size. So replicated 4 times, 20 to 25 acres. And then we also have some monitoring guidelines that we'd like everyone to think about over both the short and the long term, and the evaluation window. So again, we're really working with sites that we needed people to think about the capacity to do this into the future for the long term. So a lot of these sites have provided their own grant money, their own research dollars to help fund the implementation and to make sure that this is something that we can continue to look at and research into the future. And then, of course, we're dealing with local forest ecosystems. So there's some site-specific things that are unique to each individual forest. And so those are things like the forest type or the ecosystem, the study sites and the layout. In Colorado, we have a lot of topography with the Rocky Mountains. So elevation and aspect and slope are all things we have to consider at that site, whereas that's not something we necessarily have to think about at the Georgia site. The management objectives are specific to that local forest and their future management objectives and goals. And then adaptation approaches and tactics are ones that each forest has come up with specific to those management objectives and goals. And then again, they can come up with their final monitoring plan and determine who will be involved and engaged in helping monitor this into the future. And so we really have taken this adaptive management framework and just integrated climate change into it. And so this is from the NIAC's Forest Adaptation Resources Framework again, where of course we start by defining the area of interest, what are the management objectives, what are the timeframes we're going to do this in, and then assessing those climate change impacts to that local ecosystem and determining the different climate vulnerabilities for that area of interest using vulnerability assessments, scientific literature, other local experts and research and resources. And then evaluating those management objectives given those projected impacts and vulnerabilities. And so really thinking, are those desired future conditions reasonable given climate trajectories and impacts? And then we identify and implement those adaptation approaches and tactics, and then monitor and evaluate over time. And so this process really involves the manager's input and decisions at each step. So it's something that's really important to us in this framework is that it's really the local managers who are thinking about how to incorporate each of these steps within this process on their local forest. And so each experiment has started with a 3-day collaborative workshop. The first day of the workshop is a large stakeholder, just education and outreach day where we're providing resources and tools to the local community and to local stakeholders, whether it's the university, the U.S. Forest Service, a different private company within the region, maybe there's a local tribe that really wants to have a say in how that ecosystem is managed. So it's more of that broad stakeholder engagement on that first day. And then the second and third day is when we really dive into a smaller group of people digging into what are these adaptive management strategies and tactics going to look like on this specific site. So we work with about 12 to 20 experts specific to each site on that second and third day. We go to the field and we actually look at, okay, where would this be implemented on the ground? What would this look like? And then think about what are those desired future conditions? What are the management objectives for the specific forest? Whether it's the species composition, forest health we have to think about, forest productivity and timber sales and making sure we maintain that revenue and responses to disturbance, and then coming up with the specific tactics to meet those and thinking again about what's the time frame, what are the benefits and the drawbacks of that specific strategy or tactic, and what's the practicality of doing this into the future. And then we have the monitoring plan, where we're basically looking at a set of your normal forest composition and forest health and productivity in both the overstory, midstory, and ground layer. And then we use a forest inventory and analysis plot design. And so we're really looking at the species, the soil moisture content, the tree canopy, what are some of the ground cover vegetation that might be competing with planted seedlings, that sort of thing, all within this plot design. And so for this project, we have some core management questions where we're really trying to think about, are these adaptation approaches working in a real world context to meet local management goals and objectives? How feasible are these treatments silviculturally, as well as in terms of financial, social, and other management constraints? How does our idea of a desired future condition change with each treatment type? What does it mean to deliberately create a future adaptive ecosystem, and why would a manager choose to do this? And what trade-offs exist between the achievement of adaptation objectives and other common objectives given a region and an ecosystem type? And then on the flip side, we're also proposing some hypothesis-driven questions for this project as well into the long term. So do these treatments create significant changes to forest conditions over time? And how do they compare across all of the sites involved in this network of projects? How do hypothesized treatment responses really compare to what's being observed into the future? Do they achieve what they were designed for? What criteria emerge to enable managers to identify which treatments are performing best as we move forward into the future? And does one type of treatment consistently perform better across all of the sites within the network? And so again, just a little bit more detail about some of these sites. The Cutfoot Experimental Forest was the first one. So the workshop took place in 2013, and I believe the implementation occurred in 2014. And so this is a red pine dominated mixed species site in Minnesota. And some of the climate concerns include things like increased drought stress, increased risk of wildfire, and increased insect and disease outbreaks. The second college grant in northern New Hampshire is the northern hardwoods ecosystem. And some of the climate concerns are similar to here, where there's increased wind and ice events, increased drought stress, and loss of key ecosystem service species at this site. The Jones Center in Georgia is a mixed pine hardwood system that's on the southeastern coastal plain of the United States. And they're concerned more about drought severity and extreme weather events. They just had a large hurricane that actually went through our plot. So we're starting to do some research and analysis on impacts of the hurricane on these different treatments across that spectrum of adaptation options as well. The San Juan National Forest is in Colorado. It's that warm, dry, mixed conifer ecosystem type. So we're looking across this gradient of topography at that site. And some climate concerns are variable precipitation patterns, earlier snow melts, and increased risk of wildfire insect outbreaks. And then the Flathead National Forest, or Quorum Experimental Forest in northern Montana, which is this western large mixed conifer ecosystem. And the climate concerns are things like uncertain precipitation patterns, earlier snowpack, and increased risk of wildfire there as well. And so to dig in a little bit more into the specifics, I figured I'd talk about two of the sites, the New Hampshire site and the Minnesota site. And so this is the Dartmouth Second College Grant in New Hampshire. And so the workshop for this one took place in 2016. Again, it's this northern hardwood forest type. And some of the site considerations that we had to think about are topography here as well, and the soils, soil moisture, and that sort of thing. It's a very steep, well-watered terrain within this forest ecosystem, and it's very productive soils. And so, again, some of the climate impacts that we're thinking about at this site are increased precipitation with really high intensity events, increased frequency and severity of wind and ice events, and the increased prevalence of those non-native invasive insects and diseases. So this site also has, or we're also concerned about hemlock woolly adelgid. Emerald ash borer is an invasive that's very predominant across the northeast and midwest of the U.S., and Asian longhorn beetle. And so this map on the lower right is a map of the number of invasive insects across the US. So you can really see that the number of pests per county significantly increases with those darker colors. And so in this New Hampshire site, the amount of insects and diseases that are invasive is a huge concern. And so the current condition at the Second College Grant is this 2-age stand. It's about 87 to 106 feet squared per acre. The predominant species are sugar maple, beech, yellow birch, red maple, red spruce, aspen, and balsam fir. And so thinking about the spectrum of adaptation options, based on the local goals and objectives of this forest, we're really thinking about trying to create a multi-age structure, maintaining the hydrological cycle and erosion, making sure there's still carbon pools and living biomass, and then maintaining the productivity of this northern hardwood site. And so with our resistance treatments, we're doing a single tree selection and trying to make sure that it's multi-cohort with the current species that are there to maintain that current structure and composition of this forest ecosystem, and then increase the amount of down dead wood to help with that soil moisture and content. For resilience, making sure that this stand is able to recover and bounce back from disturbance and return to something that's similar to the prior stand condition. We're doing a group and single tree selection process, and we're creating a matrix of gaps and matrices across the stands within this treatment. And so we really want to make sure that we're increasing the compositional and structural heterogeneity of this site. We're also making sure that there's natural regeneration, and we're planting some site species that are supposed to be future adapted that are already found on this site. And then for the transition treatment, thinking about changing the structure and composition of this forest. We're doing a variable density thinning and an irregular shelter wood. Again, having these gaps and matrices to really look at impacts of canopy on the soil moisture. And we're increasing and planting off-site species that are found from the next southern seed zone, since as you saw in that study, all the species are moving north and west. And so we're picking from the southern seed zone and planting those off-site species on this property. And some of those are, let's see, black birch, big-tooth aspen, and chestnut. We had a donation from the National Chestnut Foundation, so we're planting some chestnut nuts as well. So the other example that I wanted to talk about is our site in northern Minnesota, the Cutfoot Experimental Forest. And so this is on the Chippewa National Forest in Minnesota. The workshop took place in 2013, so this was one of our first sites to be considered and the first one to be implemented. It's a fire-dependent, mixed-species, dry woodland, red pine-dominated ecosystem. But there's also some white and jack pine, and it's overly dense with a large hardwood encroachment as well. Some of the minor species are paper birch, northern red oak, red maple, white spruce, and aspen, and there's a really dense understory of hazel. The average basal area is about 100 feet squared per acre, and this stand originated from a fire that occurred in 1918, but there's been exclusion of fire in this stand ever since 1918. It's largely a single cohort of that red pine species. And so some of the climate impacts for this site, we know there's going to be increased severity and frequency of drought, warmer, wetter winters, reduced habitat suitability for a lot of those northern tree species, and again, increased threat from potentially new pests. Mountain pine beetle isn't there, but it would be really easy for it to possibly get there through wood transportation of wood products. And then the graph on the lower right is really showing the projected future climates of Minnesota. So summers under that RCP 8.5 projection, the summer is supposed to be similar to Kansas, which is a huge increase in temperature for Minnesota. And the winters are supposed to be more like northern Illinois and Wisconsin. And then we use the tree atlas to help determine which species to plant at this site. And so again, this is just a tool to look at species shifts in distribution across the eastern US. And so this helped inform some of the decisions that were made on what species to plant at the Minnesota site. And so again, here's our current condition. It's red pine dominated from this fire origin of 1918 and 180 feet squared per acre. So thinking about some of the local management goals, to maintain this red pine dominated ecosystem, we're just going to do a uniform free thin, make sure we're still providing wood products from this red pine species, and maintaining the other species that currently exist on this site into the future. For resilience, thinking about being able to bounce back from disturbance, we're doing a variable density thinning, and then again, we want to play with the structural heterogeneity and composition of the site. So we're looking at gaps, skips, and matrices, where we're playing with the crown composition to change the amount of light reaching that soil and impacting the ground cover of the stands that we're working in. We want to maintain that red pine dominance so that it's still similar to the current structure and composition, but also plant more future adaptive native species that are already found on this site. And then with the transition, thinking about transitioning into this future ecosystem, we're doing an irregular shelter wood. We're continuing to have these gaps and matrices to have that structural heterogeneity in the composition and structure. And then we also are planting future adaptive native and novel sites. So some of the other species that we're planting include things like white pine, jack pine, red oak, bur oak, red maple, and then also butternut hickory, black cherry, and ponderosa pine. And so ponderosa pine isn't currently found on this site. We have selected 4 different genetic variations of ponderosa pine from Kansas, Nebraska, and 2 from South Dakota, which are the easternmost range of ponderosa in the United States. And we're planting all 4 of those in our transition plots at the Minnesota site. And so for ponderosa pine, when we were looking at the future climate models, red pine is not supposed to do well in the future. And so ponderosa pine is something that has a very similar ecological niche as red pine, and so we wanted to plant that at the Minnesota site. There's also a history of plantations of ponderosa pine that have been planted in Minnesota as well. So there's ponderosa already in the state. So again, we're thinking about assisted migration a lot at this site. And then this is the layout of what it looks like on the ground. So again, with the Minnesota site, we have done 5 replicates instead of 4. And we have our control plots and resistance. And then within the resilience, we're creating these gaps, skips, and matrices. And then the transition, we have these gaps and matrices as well to really look at that canopy impact on soil moisture. And so at each plot, we have a soil moisture probe. We're starting to get data from that. And then we also have planted over 250,000 seedlings across the 500 acres of this Minnesota site. And so we're starting to get a lot of cool data on the seedling survival as well. And so just some future research for the ASC project. We are doing a workshop with the Petawawa Research Forest in July. And so we're going to really focus on white pine within this system, and it's going to be a great complement, I think, to what we have with our Minnesota and our New Hampshire sites. And then they're currently working on creating a vulnerability assessment to help guide their forest management planning. And then we'll come in and we'll, at this workshop, think about what does this look like across a resistance, resilience, and transition adaptation spectrum. And then some fun facts about the ASC project. There's over 2,100 acres that are currently being harvested or designated as no action and being measured as a part of this project. There's 3 U.S. Forest Service national forests that are involved and engaged in this process, as well as the research stations involved with those U.S. Forest Service plots, and 2 large private entities, the Dartmouth Second College Grant and the Jones Ecological Research Center. We have 6 different universities that are engaged in project research, and that number continues to grow as more people are interested in doing wildlife monitoring or bird migration monitoring at a lot of these plots. We've planted, as I said, a lot of seedlings, over 275,000 in Minnesota, 4,000 in Georgia, 6,400 plus chestnut seeds in New Hampshire, and we're planting 40,000 in Montana. And these ones, the Montana site and the Colorado site haven't been harvested yet, but the the workshops have occurred and we're just waiting for the contractors to get in place. And the Montana site, we're really going to be looking at planting white pine, Doug fir, and ponderosa, and we're picking species that come from lower and higher elevations and planting them across the slopes at the Montana site to think about the impacts of and the survival of those lower versus higher elevation genotypes. We are doing a lot of education and outreach about the project, which has been really fun. So reaching more people, getting better ideas, creating more collaboration and partnerships. Again, we're expanding Canada, which is super exciting, and we're beginning to work with what we're calling this tier of affiliate sites. So they might not necessarily be able to meet the 400-acre criteria, but because they're in urban areas. So we're doing a workshop at the end of March in the middle of St. Paul, Minnesota, to really think about what does this look like within an urban center, and how do we help adapt urban forest ecosystems to a changing climate. So some of the key strengths of the ASC project, we had a collaborator meeting where we brought everyone together last year, and this is determined by the local scientists and managers who all came together for this network. And so the key strengths that we think are really that this is a true co-generation project between scientists and managers at all of these sites. It's mission critical to the U.S. Forest Service, and that helps us with funding. And it's a really ethically important research project trying to make sure we have forests into the future. We wanted to make sure it's scientifically robust through these replicated long-term experiments, and want it to be applicable to landscape scale context as well. We're also encouraging stakeholder engagement and communication, and particularly through these workshops where we bring in the larger stakeholder group in the area, and make sure that there's still long-term dialogue and outreach to the management community. So a lot of these, another criteria that we have is that it's an outreach and education site as well. So people are coming in for tours, it's a demonstration site at all of these sites, so that we're continuing to have that outreach component as well. And then we're really trying to put that adaptive management theory into practice at all of these different sites. And so I think this is our team, the Adaptive Silviculture for Climate Change team. I think it's a pretty cool project. So this project really is trying to advance our understanding of how forest management can foster those adaptive responses to a changing climate and advance communication of climate change adaptation at a national scale and international scale now. And so as managers, thinking about climate change can be really daunting, and with all of these uncertain futures and models and projections, it can be really hard to wrap our mind around sometimes. And so the ASC project really is trying to look at opportunities to continue managing our forests to meet our local values and goals and make sure that we maintain these diverse, resilient, valuable forests into the future. So with that, I'll open it up for questions, and I would we have a website, so it's the adaptivesilviculture.org. There's also a Journal of Forestry paper by Mabel et al., and then that's my contact information, and feel free to email me with any additional questions you might have after this workshop.